Okay, so slope-intercept form. I want you to say slope-intercept form. Go ahead. Alright, so slope-intercept form. So the reason I had you say it is so that it's stuck in your brain now. What is important about slope-intercept form? Just take a wild guess. Nope. Getting there. What are the important parts of slope-intercept form? The slope, good. That's one. What's the other one? The intercept. There you go. Okay. That's why I had you say it. Okay. Slope-intercept form. It's a no-brainer. The important parts of slope-intercept form are slope and y-intercept. Okay. Basically, the goal of today is to be able to graph a line. Okay. Any equation that's given to you, so that you can be able to graph it. And I'm not talking make an input-output table and graph that way because that takes way too long. Okay, we want to look at the equation and be able to graph it pretty quickly. That's what the goal of today is, okay? So, up at the top, the slope-intercept form. So I don't have enough room, so I'm just going to do slope-int for slope-intercept form of an equation is. Does anybody remember? I'll help you. I'll start with y equals. That's it. Why is my stylus not working? Oh, I deleted all of it. Let's try this again. Y equals, and then you guys said mx plus b, right? Y equals mx plus b. The parts, okay? X and y will always be there. Do you know what m represents? Slope. It's always the slope, right? We talked about that last unit. So m is the slope. And that would leave b as my y-intercept. Okay, so my y-intercept. So everybody show me the y-axis with your arm. Good, so my y-axis is the up and down axis, right? So what do you think of when you think of intercept? Travis?
Isn't it like the point where it goes across the y-axis?
Good. You took it way more technical than I thought you were, but that's perfect. What simple words that we hear every day do you think of when you think intercept? Yep.
Where the 2 points meet.
You guys are being way too mathematical for me. Intersection, okay? The intersections of roads. What does that mean? Where two roads cross. What other word do you know that has intercept in it?
Interception.
There you go. A football interception. What's a football interception?
The guy takes the ball.
The offensive pass meets the defender, right? Where the offensive and defense cross. Okay, or a change of possession happens. Okay, so going back to the technical definition, a y-intercept is then when my line crosses or meets the y-axis. Okay? All right, so it's important for us to be able to put equations that are given to us in slope-intercept form. So I'm going to go ahead and tell you for 1 and 2 that neither one of those is in slope-intercept form. Okay, 1 and 2, neither one of those is in slope-intercept form. I want you to take a quick 30 seconds with your partners and try to figure out why I am saying 1 and 2 are not in slope-intercept form. Go ahead. Okay, I heard lots of good things. Holland, can you tell me what you said? The y is not alone. That is the absolute one thing that makes slope-intercept slope-intercept. The y is not alone. Okay? So on these problems 1 and 2, our goal is to be able to get y by itself because I cannot identify m and b until I'm in slope-intercept form. So this is the reason that I gave you the homework last night that I gave you, solving for a particular variable when there are other variables involved. Okay? So on number 1, what is my first step in getting y all by itself? Alex?
Subtracting the x.
Good. I got to get rid of x with an opposite operation. So I would subtract x from both sides. So I have negative 2y equals, are 2 and x like terms? No, so they go side by side. I just do what I see. I see 2 minus x. Okay. And then lastly, I need to divide by negative 2 to get y all by itself. And I have to divide every single piece by negative 2. Don't just do one piece and leave off the other. I have to have divided by -2 on both sides, or on every piece. So now my final answer, y equals, what's 2 divided by -2? -1. And then remember, we like to see slope as a fraction. Okay, we really like to see slope as a fraction. So that being said, what number is in front of x right now? -1, right? So this is a -1 up on top. So what is -1 divided by -2? Please don't say 2. Well, it's a negative divided by a negative. Positive. What's 1 divided by 2? 0.5. Okay? And remember, we like to keep them as fractions. So, if you can't make it a whole number, and you can't reduce the fraction at all, just leave the fraction as is. So I'm going to do 1 over 2, and the x just pops out to the side of the fraction. So I have y equals -1 plus 1/2 x. This is slope-intercept form. Okay? This is now in slope-intercept form. Once I have it in slope-intercept form, now I can identify m and b. So I want to go back up to our slope-intercept form. And I want you to take a quick 30 seconds and talk with your partners about how do we know which one is M and which one is B. Go ahead. Okay, so what do we think? Yep. Sydney?
M is the one with the variable and B is one without.
Okay, so M is always going to be beside X. B is always going to be by itself. So as soon as I have Y all alone on one side of the equal sign, I can identify M and B based on what is where. And please do not fall into the trap of saying the first one is M and the second one is B. Because I could just as easily, you don't necessarily have to write this, but I could just as easily have Y equals B plus MX. Doesn't matter what order I add in. It's not that M is first and B is second. It's that M is next to X and B is all by itself. So going down to my solved equation that I put in slope-intercept form, my M is the number next to X, which is 1/2. And my B is the number all by itself, which is -1. Make sure to take the sign with it. Okay. On number 2, I'm going to give you a little bit more freedom here. So on number 2, I just want you to start. I'll give you about a 20-second head start. Solve for Y. Go ahead. Okay, so I start by getting rid of the 2x term, and I'm going to do an opposite operation. So I would add 2x to both sides. Then I have 3y equals -12 plus 2x. Or you could have 2x minus 12. I don't care what order you put them in. Lastly, I divide by 3 on every single piece. And I end up with y equals -12 divided by 3 is -4. And 2 divided by 3 doesn't turn out to be a whole number, doesn't reduce at all. So I'm just going to leave it plus 2 over 3x. Please do not make it 0.6 or 0.6 repeating or anything like that. Remember, I don't care if you make a y-intercept into a fraction. That's fine. I'm fine with that. But do not ever make a slope please do not ever make a slope a decimal. So y-intercepts, I don't care if you make them decimals, but slopes, keep them as fractions because we like to see that rise and run. Okay? All right, so here I can now so now that y is by itself, I can identify my m. So class, what is m here? 2/3. Good. The number next to x would be 2/3. And then my b is the number all by itself, which is -4. Okay, you have to try these problems to work on with your partners. Actually, for the sake of time, let's just do 4. So skip 3, just do 4. Go ahead. Okay, so I want to get y all by itself, so I need an opposite operation here. So I would have to get rid of -2x by adding 2x to both sides. So I have -6y equals 2x, right? 0 plus 2x is just 2x. I divide by -6 on both sides. And I get y equals, I know it's going to be negative because it's a positive divided by a negative. I can divide a 2 out of both 2 and 6, so I'm left with 1 over 3x. So I have y equals 1/3 x. This looks a little bit different than we saw up above. There's something missing, right? My x term is still there, but I don't have another number out there. So here, what is my m? Negative 1/3, right? That's the number next to x, so negative 1/3 is there. That's not the missing part. So negative 1/3 is my m. What about b? Because now I know my b is missing. Okay? If I had to add something back here, but I did not want to change the equation, it would have to be a plus 0, right? Plus 1 would change it. Plus anything else would change it, but 0 would not. So that's when I know my y-intercept is 0. So, just really quick, because we're about to step into graphing here in a minute. If I have a y-intercept of 0, where is my line going to cross the y-axis? This is 0 right here at the origin, right? That's what a y-intercept of 0 would look like. Okay. All right, so now can I get a comfort level on solving for y? Getting them into slope-intercept form, identifying slope and y-intercept. Okay, let's look at graphing. Okay, so example 2. Can I right off the bat identify slope and y-intercept on example 2?
Yes,
Why do you say yes?
because it has the equation there and the numbers are there, so you can just plug.
Being a little too vague for me. Travis?
It's in slope-intercept form.
Okay, so specifically y is by itself, right? So since y is by itself on example 2, I can right off the bat identify m and b. Okay, so here my m is the number next to x. And remember, I always want slope to be a fraction, especially if I have to graph it. So how can I make this slope a fraction? Because it's just 3. 3 over 1. Just anything I can put over 1, right? So my slope here is going to be 3 over 1. It's kind of hard to read. 3 over 1. There we go. And then my b, the number all by itself, is negative 1. You know I am a person that likes sayings, right? Little phrases that will try to help you remember stuff. So here's my phrase for graphing, okay? My phrase is b is where you begin. B is where you begin. M is where you move. So anytime you're graphing, B is where you begin, M is where you move. So graph the y-intercept first. That's B is where you begin. So graph the y-intercept. Again, everybody show me the y-axis with your arm. Good. So my y-axis is the up and down axis. So I want to mark on that y-axis negative 1. So I'm going to go just down 1, and there is my y-intercept. Okay, so once I have the y-intercept down, then I use the slope, which we know as rise over run, to plot other points. I want you to put as many points on the graph as you possibly can fit. Okay, the reason I say that is because the more points you put on there, the less likely you are to make a mistake. Because if you put a bunch of points on there and you see one is out of line, you know you made a mistake on that line. Whereas if maybe you only plot 2 points, but you mess up on the second point, your line's going to be completely wrong. Okay, so plot as many on there as you can. So 3 over 1, and that's why I like my slope as a fraction, because I can count my rise and run. So 3 over 1, that'd be up 1, 2, 3, and over 1. Up 1, 2, 3, and over 1. I can also go the opposite direction. So instead of going up and to the right, I'm going to go down and to the left. So down 1, 2, 3, left 1.
Mr. Craw.
Yep.
But I thought that B was, oh, no, never mind.
Okay. So here's my second saying about graphing. So first one is B is where you begin, M is where you move. My second saying, and you guys have heard this one before, is read it like a book. We always want to make sure we double check our slope. So how do you read a book? Left to right. So going left to right, is my line going up or down? If I'm moving left to right, my line is going up, which means I should have what kind of slope? Positive. My slope is positive. I know I've graphed it correctly. Okay. All right, why don't you go ahead and do the try this at the bottom of that page. Do the try this at the bottom of that page together with your partners. Go ahead. Okay, so my, excuse me, my equation is already in slope-intercept form, so I can identify m and b. So m in this case is 2, and I make that a fraction into a fraction by putting it 2 over 1. And then my b, my y-intercept is 4. So I start with my y-intercept. B is where I begin. So up 1, 2, 3, 4 on the y-axis. And then m is where I move. So 2 over 1 tells me to rise up 2 and over 1 this way, right? I would go up and off the graph. So since I can't go up and off the graph, I have to go the opposite direction. And this is when you especially have to be careful. Okay, because just visualize, okay, so if I was going up over here, I'm now going to have to go down and to the left. So I go down 2 and left 1 for my next point. Down 2 and left 1. Down 2 and left 1. Down 2 and left 1. Okay, make sure you double check. Read it like a book. Going from left to right, where's my slope going? Or where's my line going? Left to right, where's my line going? It's going up, right? Going left to right, it's going up. So which would mean it's a positive slope. That matches my equation, so I know I'm good. Okay? All right, let's scroll down to the back page. And now I want you guys to put it all together. Okay? So try 5 together with your partners. Try 5 together with your partners. I'll give you a little head start, and then I'll come through with my stuff, okay? So go ahead. Okay, so I need to get y by itself, so I am going to get rid of 6 first. And then I'm also going to get rid of 3x with an opposite operation. So 2y equals 6 minus 3x. Last step in getting y all by itself is divide every piece by 2. So my final answer, well not my final answer, but my slope-intercept form here is y equals 3 minus 3 over 2x. My fraction doesn't reduce, it doesn't become a whole number, so I just leave it 3 over 2. So then my slope is negative 3 over 2, because that's the number next to x, and my m is 3, or excuse me, my b is 3. So b is where I begin on my graph, up 1, 2, 3. And then a slope of negative 3/2, so I'm going to go down 1, 2, 3 over 2. Down 1, 2, 3 over 2. I can't go down anymore. I can't go the opposite direction up anymore. So that's that. Please make sure your lines extend all the way across your graphs. It's just good practice. Okay? And can I now get a comfort level on graphing? Alrighty. Last thing we're going to look at is going the opposite direction. So if I am going from the graph to the equation, so I don't feel like I need to help you on this. Okay? Follow the direction, step 1, step 2, step 3, and then do the try this together with your groups. Go ahead. Okay, so walking through my steps here, I need to find the slope. So remember, pick 2 good points, calculate your rise and your run. So I'll pick this point because it's going to be important later anyways. And it looks like I can pick this point also. So I go down 1, 2, 3. And since it's down, that's a negative. And then I run over 1, 2, 3, 4. Sorry, I told you wrong. On the slope. No, her. Okay, so it's important that you pick good points. Calculate your rise and run, so that's negative 3/4. Okay, and then I also need my y-intercept, so I come back over here. My line is crossing the y-axis right here at the y value of positive 1.
Why did you go down 3? That was 2.
I got negative 2 over 4.
Yeah.
Like if you go up.
I could probably make a case that did some of you pick this point right here?
Yeah.
Okay. when you're putting a line into Microsoft Word, it doesn't make it exact, and it's kind of hard to tell sometimes. So I could probably see negative 2/3. I'll make sure on the tests and quizzes, though, that the lines are very clear where they go through and where they don't. Yeah, that's usually what I end up doing for the tests and quizzes. I just draw them in after I print it. Okay, and then writing my equation. So I have a slope and a y-intercept. Remember, it is y. So y equals m, so negative 3/4 x plus b, which is 1. Or you could have 1 minus 2/3 or 3/4 x. Negative 2/3 is probably fine too, just depending on which point you picked. Okay, questions on this? All right, so we know how to do both, right? We know how to go from given an equation in any form, turning it into slope-intercept form, graphing it. We also know how to take a graph that we're given and write the equation for it, okay? All right.